Hello, my name is Jack Zamudio, and I am a first-year student at Chapel Hill, and my ambition is to become a doctor. I took both Chem 101 and 102 during my first year at Chapel Hill, and this is a big adjustment from high school science. By my standards, I really struggled through 101, even though I worked really hard. However, I have witnessed the positive effects of that hard work in 102. I want to become a peer mentor so that I can help students do as well as they hope to in this course. I acknowledge that chemistry has everything to do with understanding concepts rather than memorizing problems, and I hope to guide students towards effective learning and studying. I believe that those who are driven and effectively study can be successful in this course.
Given a solution of 50 milliliters of 0.1 molar hydrogen fluoride, Ka of HF is 6.8 times 10 to the negative 4, what is the pH after adding 25 milliliters of 0.2 molar NaOH, and is this a buffer? So what we need to consider first is what's in our solution. So we have HF, and then we have Na plus, and we have OH minus. And we think the strongest acid will react with the strongest base. In this case, OH minus being the strongest base and HF being the strongest acid. So we write an equation such that HF reacts with OH minus, and this will be a one-sided arrow because OH is a strong base, meaning that it will completely react, or it will react till completion. And this will form water and F minus. And so we need to consider moles of our reactants because this is a stoichiometry problem and not an equilibrium problem. And so we do this we calculate moles by multiplying the volume times the molarities provided. And we find that we have 0.005 moles of HF and 0.005 moles OH. We don't need to consider water. Because the stoichiometry is 1-to-1, we will produce 0.005 moles of F minus. And so now we're not done yet because we need to consider, well actually, first we can say that this is not a buffer because we have completely exhausted our buffer of HF and F minus by adding enough NaOH to completely exhaust the buffer. And so now we have what's left, which is F minus. And so we need to consider F minus will react with water that's in solution to form, and because it's a weak base, it's not a one-sided arrow, to form HF and OH minus. And so now we need to find the concentration of F minus and not the moles. And we do this by taking 0.005 moles and dividing by the total volume, meaning the 50 milliliters we began with and the 25 milliliters we added. So our molarity will be 0.0667 molarity. We don't need to consider water, and we'll say that our starting is 0. We'll lose X plus X plus X, filling out our Rice table. And so our equation, X and X. And so we're given a Ka of HF, but we need to convert that to a Kb, which is 1 over the Ka, and that is 1.47 times 10 to the negative 11. And so we can set up our equation. 1.47 times 10 to the negative 11 is equal to X squared, products over reactants, 7 minus X. And so we solve this by first considering the 5% rule and by omitting the minus X, and then we will go back and check later. And so when we omit the X, the minus X in the denominator, we find that X is equal to 9.9 times 10 to the negative 7. And this divided by the initial concentration times 100 equals 0.00148%, which is less than 5%, therefore we can carry on using 9.9 times 10 to the negative 7 as our X value. And so we can say that because we know that's our X value, that is the concentration of OH in our solution. And so we can say that our pOH is the negative log of 9.9 times 10 to the negative 7, and that is 6.00. And so we can find our pH by taking 14 and subtracting our pOH, which is 8. And so our pH, after adding 25 milliliters of 0.2 molar NaOH, is 8.